Hi there. I'm going to do a non-scripted, but somewhat set up kind of coding example. This is a companion video to that C and not WebAssembly, C and assembly video I did. Please check that out. I'll put it on the screen here right above so that you can click on it and view it and know roughly what I'm talking about here. But basically, this is since a lot of people want to see code and see things actually run, I set up these C file examples to show you, what the C looks like and then what the assembly looks like. The actual examples will look a little different because my processor is going to be a little different than what the examples use. Honestly, those were just kind of AI generated stuff. Yes, AI generated. Um, that I threw out there that I think they're close enough, roughly accurate, but these will be actual concrete examples I can show you. So here's for the first test. So we're going to start with one of the first example. I'm going to really look at two examples here. So the first one is that function example I started in the video. So it's just simply an add function and just so it's runnable. Here's the main function here. And of course, if I were to compile it, which I'm just gonna use a thing here to kind of run it, great. And so if I run it, there you go. The result is 5, which that's accurate. 2 plus 3 equals 5. So there we go. So it is runnable code. You can run it so you just get assembly, which I have that here. Yeah, so you just write, if you just do for the function. Now I don't have anything to kind of do a one-to-one mapping. It's a lot longer. It's like 75 lines versus 11, right? That's quite a bit longer. But here's that add function there, right? Here's that add function. It's kind of moving some memory around, popping out the memory, returning values, right? So that's going to be that's all going to just correspond to a plus b there, right? It's doing all of this just to return a plus b, right? That's quite a bit. Yeah, doing more manipulations to start of the main method. That's actually running it. So probably be able to see it run add. Yep, there we go. There's call add. So it's actually calling that function. It's calling the print statement here. You can tell. Yeah, so you can see that. And then what else? Can we see it returning 0? I believe this is just returning 0. It just calls it and proc. So yeah. So that's roughly what this is doing. But as you can tell, I can barely read it myself because this is really, again, this is highly optimized, somewhat complex code even for simple functions. So if we did the same thing for the loop C, let's see. We did the same thing for the loop C. Let's go here. Yeah, again, it's 60 lines versus 10. And roughly, what would this look like? So we didn't have an extra method, so, right, we just had the main method, so that's why there's no other method. So there's our main. Again, we're doing some memory manipulation here. Here it is. This is what I was trying to find earlier, and I could not, is a jump. So because we are looping, and traditional programming, especially when you look at assembly, doesn't have a concept of a loop. That's something that has to be, of course, explicitly programmed into even a low-level language like C. So because of that, wrong one. Because of that, you need to instead use basically jump, where you have to jump to a certain line, and then if you move, and then if you satisfy a certain condition, in this case, moving to L2 right here. So we move to L2. Leave, I believe, is something like, what is it called? I think, forgot what well, I think, yeah, there's like I haven't done this in a while. We don't do spaghetti coding nowadays, but that's essentially associated with something like, oh, you jump to this line and then you exit out of the certain context, right? I think that's what that probably is. And then you return that. Oh yeah, and there's this one's referencing L3. I actually, again, I'm not scripted here, so I don't 100% remember what JLE stands for, but it has something to do with referencing L3 and all the calls, like it's calling printf. Basically, it looks like it's running the main kind of stuff here, right? The summing, printing. Looks like that's what it's doing. Um, yeah, it looks like that's what it's doing, what it's referencing when it's calling that. And all in all, as it's doing that, it's jumping basically back and forth. I'm trying to figure out, so we have the jump, right, to jump L2, but I'm trying to figure out where the jump back is. Like, where's the condition where, like, oh, if it's within this certain, let me see. Again, I'm not assembly programmer, so am struggling to kind of read where it's going back to the line. Somebody in the comments can help me out there. But yeah, but we can at least see the jump here where we're jumping to L2, and I'm supposing that there's some logic in here that if done right, it just kind of jumps back, right? It does this L3 thing. It calls it L3 logic here, which again, I believe is our for loop here. And then just keeps running it until it's done. So believe it or not, this all is associated with this. And also note that, again, the examples I showed in the video are fairly naive, not perfect. If you ran it one-to-one, like on a file, those will fail, because I know one of the for loops, like, and I know because I accidentally ran it, is that, one of the loops doesn't have this defined. It's just kind of assuming that you have it defined somewhere else. Note that. So yeah, it's kind of a naive assumption of how it very loosely works. But you can tell it does look somewhat like this, but it's a little more complicated and way more, I would say, optimized for what it's trying to do. So yeah. So anyway, that's why we don't really do assembly. Because if you had to do it by hand, very simple code like this, that runs fast enough on C, would take quite a bit. Again, there's probably more naive, simpler optimization or simpler versions that could probably do the same thing. But again, I'm not an assembly programmer. I had to look that up / ChatGPT, some of those examples for assembly. I'm not an assembly programmer. And the fact of the matter is, most aren't, right? Even most low-level programmers are not assembly programmers. So C, C for creating your functions, doing your loops, etc. Those are good enough for low-level systems programming. So that's why we don't really do assembly a lot. It's been optimized enough, so it's fast enough, and it's often way too complex. And inefficient, really. It's inefficient from a developer's standpoint, right? Like, if you have to write out a file and debug it forever because it's so complex, even if you're squeezing out just a little bit of performance out of it, right? It's just kind of not worth it, right? The time to value ratio, I guess you would call it, is just not there. Anyway, so yeah, this is my first kind of live-ish, live from my perspective at least, because again, this is not scripted. It's just me rambling. I'll probably edit it a little bit, but not that much. And showing you kind of what this looks like with real code. So I think that'll be it from me. This is not meant to be super duper long or crazy in depth, just kind of a simple code example of what that looks like and what that main video for this was talking about. So thanks for watching. Do like and subscribe for more techie talk, as I like to say, at least the AI clone of me likes to say, for more techie talk on the Techie Shop. And stay tuned, because I'm going to try to do more of these when I get the time, but time is limited. That's why I do some of the AI generated stuff. But I am involved. I am editing and looking at those. And I am looking at your comments and suggestions. I appreciate those. Please keep sending those to me. And again, like and subscribe, and I'll see you next time. If you like this video, watch this video here for more tech talk.